Hi, the title of this lab experiment is the force between the electrical currents or the current balance lab. In this lab, we will use this equation, force equals mu sub 0 times current 1 times current 2 times the length of the two conductors, all divided by 2 pi times A, which is the spacing in between the two conductors, to experimentally find a value for mu sub 0 and then compare it to this value shown here. So now let's look at some background information on the right-hand rule. For this experiment, the first right-hand rule is going to follow this when the current is going to be your thumb and the magnetic field is going to be in the direction of your fingers. And for the second right-hand rule, your current is going to be your thumb, the magnetic field is going to be in the direction of your fingers, and the force is going to go in the direction of your palm. So now let's use the right-hand rule and apply it to this situation here. If you want to find the force on wire 1, then you apply the right-hand rule where this current here is going this way, so the magnetic field is going towards you, and then the force on wire 1, the current is going this way, the magnetic field is going towards you, and the force is going up. Then if you want to find the force on wire 2, you look at the current on wire 1, where the wire is going this way, so the current is going this way, so the magnetic field is going towards you like that, and the force right here, the current is going in this direction, the magnetic field is going towards you, and the force is going down, and this creates a repulsion force between the two wires. The equipment you need for this procedure is a current balance, a laser beam with a support, a white paper, a vernier caliper, a ruler, level, ammeter, a set of milligram masses, and a variable line auto transformer. The wiring is based on the connection between the auto transformer to the AC ammeter, then from the AC ammeter to the lower conductor, then the lower conductor to the upper conductor, which is connected in series, and then back to the transformer. The first thing that you want to do is make sure your setup is level by using this device and making sure that the bubble is in between the middle of the two lines. You also want to make sure that the transformer is far away from the setup so that it doesn't interfere with your results, and it also works best if the spacing between the two conductors here is about 0.5 millimeters. The first thing that you want to do is add a 5 milligram mass to the setup, but you want to be very careful because it is very sensitive. You're going to add a little bit of current, and you're going to walk over to the paper and you're going to draw a dot where you see the laser beam. Okay, and after you do that, you're going to add some more mass to the setup, and you're going to see that the position of the laser beam is going to change. And when you do that, you're going to adjust the current so that it is centered on the dot that you drew before. And after you do that, you're going to record the current that you see on the ammeter, and you're going to repeat this for several different masses. Using the data from your data table, you're going to construct a force versus current squared graph, and from that you're going to find that the slope is represented by this equation, where L is the length of the conductor and A is the spacing between the conductors, and you're going to use this information to find the value of mu sub 0.